This Triceratops head is now the largest animatronic head that I've ever created. This was once again done using servo motors and an Arduino circuit. But one thing that I didn't bring up the last time when I was making the Heterodontosaurus was exactly how you make the circuit, as well as how the coding actually works. So what I'm going to do for this tutorial is first show you how to make the circuit and create a code for it. This is also a reminder to myself in case I forget in the future and I have to download Arduino all over again. Keep in mind that I'm also going to be connecting the servo motors to a joystick that came with an Arduino starter set. So for this animatronic, I'm connecting once again, I'm connecting two servo motors to the same Arduino Uno board, but this time I'm also connecting them to a joystick, and that's something I've never done before. I was gonna use IR remote, but the signals are inconsistent, so it wouldn't really work. And this was done with the help of some trainers at Kiddo Code because I'd forgotten a bit about what I've learned. Here's a reminder of some basics in case I forget. Now, the joystick has 5 ports. There's a Y and an X. These are supposed to be like Cartesian coordinates, so Y is vertical, X is horizontal. Now, Y is connected to A0 and X would be connected to A1 on the board. Alright, wait, let me okay. And then there's 3 other outlets, B, V, and G. V stands for voltage and G stands for ground. Okay, I can't remember what B stands for, but B would be connected to port labeled 2. V, voltage, would be connected to 3.3 volts on the board. And ground would be connected to one of the ground ports on this part. Now we move on to the servo motors. I've connected 2. Once again, it's SG90. So take note of the colors of these wires. Red is supposed to be connected to power. I can't remember what orange represents. And brown is connected to ground. In this case, this is going to be very important for the code. The orange wire must be connected to number 10. The red is connected to the port with 5 volts. And the brown is just connected to regular ground. For this other motor, orange would be connected to port labeled 11. Red also connected to 5 volts. I've stuck 2 in the same port. I'm not sure if there's a caution against that, but it still manages to work. And brown connects to another ground port. So essentially, red is positive. Positive goes to a power source, and brown is negative, and negative goes to ground. To first make the code, you have to download Arduino IDE. You also need a specific version. I have 2.1.1 because it has a demo for servo motors specifically. Keep in mind this board is Arduino Uno, and you need to specify this in the sketch. You also have to specify which port in the computer it's connected to. First, you need to upload this specific code into your sketch. This is so that you can map the exact signals being given off by the joystick. You will then open your serial monitor and observe all the signals it's giving off. Now this is what you should see on the serial monitor. All of the signals are infinite and they don't seem to stop. Take note of the coordinates when the joystick is at its origin. Afterwards, you should move the joystick up, down, left, and right, and take note of all of the coordinates that are present. For instance, the coordinates with x equals to 0 and y equals to 512 is indicative of moving the joystick to the right. With that, you should produce this exact code, but you have to customize it to account for the different mapping signals that are given off by the joystick. So if I zoom into the X map and Y map lines in the code, you can see that this is how I've laid down my signals. So that's 0, 667, 0, 180, and the same is true for Y map. However, if we go back to our previous example for a different serial monitor, we must put it as 0, 1023, 0, 520 for the X map. Note that the delay is 30 milliseconds, and that the pin numbers must be specified. In this case, they are pins number 10 and 11. Now I want the animatronic head to resemble this green screen animation that I got off of YouTube, so that I can make use of both of them in the near future. So now comes the creation of the head. The eyes are teddy bear eyes that I bought from Spotlight, and the mechanism for the eyelids is essentially just a loop of wire with a hinge attached to it so that it seems to blink. So the loops of wires will be attached to a servo motor so that when the motor moves, they move up and down, and a latex sheet can be attached to these wire loops so it would look like an eyelid that blinks. How you want to make the eyelid mechanism is very much up to you, because my mechanism doesn't work very well. You can use your imagination if you like. Well, the lower jaw wasn't very difficult to create and attach to the servo motors. During this time, I also made use of some silicone rubber to make a skin mold that would allow me to make more rubber hinges, but with a skin texture. But then came the frill, because it has to round out but still be somewhat flat. Again, use your imagination to fill in the gaps. Both horns were made out of cardboard and masking tape. Must be about the same length and shape. Here's where I'm adding the epiccipitals or spikes to the frill. This is according to the animation once again. This is likely meant to represent a teenage Triceratops of sorts, because epiccipitals really only appear in juvenile Triceratops. Once again, each of the scales were made using a special air-dry paper clay. Note that all of these scales are large, pebbly, and polygonal. On the neck are some small regions that look a bit like human nipples. This is an actual thing in the fossil record where we actually have mummified Triceratops skin. And I suppose that's all there is to it. Have fun with your new animatronic Triceratops. Apologies if I wasn't able to get every single step of my process on video. Now that you've seen the video log, let's now see my animatronic Triceratops in action in a documentary.
Triceratops. This one's a young mother who's just left her clutch of hatchlings to go foraging. She preferably feasts on cycads and ferns, which she snaps off using her tough beak. She has 800 teeth in her mouth that slice together vertically during mastication so that she can actually chew her food. Her majestic frill and hide are covered by large polygonal scales, with randomly placed protective projections that make it more difficult for predators to bite into. However, her frill has a blind spot, and she doesn't notice that she's being trailed. Triceratops are not normally social animals, and so don't often form herds. This makes them especially vulnerable to predators. She doesn't realize she's being watched. It's a baby Triceratops who's been separated from his own mother. Smell is very important in animals like Triceratops. Mother and child imprint on each other through the unique scent that each of them give off. She will not look after an infant with a different smell. She does not recognize him. To her, he is nothing more than a threat. Of course, this is no time for any infant to be on their own.